everyone, we are continuing our conversations about the difference of proportions. Last video we talked about the sampling distribution, the shape, the center, the spread. We looked at those formulas. It was all beautiful. So now we're going to talk about confidence intervals. This is our general formula for a confidence interval. This is the formula that you see on the formula sheet. You start with a statistic, right? Statistic comes from some sample data. And then you add or subtract your critical value. For proportions, we use a z-star. For means, we use a t-star. And then we multiply that by the standard deviation of our statistic. This part, after the plus or minus, we call our margin of error. So, in our important notes box, we have this. The 2 sample z interval for a difference between 2 proportions. That part right there, the top where it says 2 sample z interval for difference between 2 proportions, that's the name of our test, or the name of our method that we're doing. So when we're in our 4-step process and we're doing our plan, or if we're using the panic and we have to name the interval, that's the name of the interval that we are constructing. So as long as our 3 conditions are met, normal, random, and independent, and they have to be met for both samples. Both samples have to have the conditions met. Then our confidence level, or interval, for the difference of our proportions is given by that beautiful formula there. Not explicitly on the formula sheet, right? It's just the general formula, but this part of it is on it if you look down where it has the 2 proportion stuff. Z-star is a critical value for the standard normal curve as long as the area C is between those 2. Okay. Notice how we're using p-hats as opposed to p, right? When we're doing a confidence interval, we don't know the population proportion. We're trying to estimate it, right? That's why we don't use p. We don't assume we know p. We're trying to estimate it using p-hat. And these formulas always have like a sub 1 and a sub 2. Feel free to change the subscripts to represent the problem. So like in the one from the last video, I used M for Michelle and J for Julie. If we're using years, maybe one is subscript 2009, one subscript 2010. Change it up so that it's clear to you which one is which. It'll be easier than when you define your parameters. So just recap, what are the conditions, right? The assumptions that we have to have. Random. Both sets should either come from a well-designed random sample or from randomized experiments. Normal. Both sets of data must meet the normal approximation. So multiplying 4 different things and seeing if they're larger than or equal to 10. And then as far as independent, both sets of data must be independent. When we're sampling, sample size should be no more than 10% of the population, right? That's our 10% condition. You have to check the condition for each separate sample. Okay, so this sample is less than 10% of this population. This separate sample is less than 10% of this separate population. Okay, so make sure we're assessing it separately. So let's go through an example together. Have opinions changed about gun control? Gallup regularly asks random samples of U.S. adults their opinion on a variety of issues. In a poll of 1,011 U.S. adults in January of 2013, 38% responded that they were dissatisfied with the nation's gun laws and policies and want them to be stricter. In a similar poll of 1,011 adults in January of 2012, only 25% agreed with the statement. So we're going to do 3 things here. We're going to explain why we should use a confidence interval instead of just saying that the percentage increased by 13 points. And then we're actually going to construct and interpret a 90% confidence interval. And then kind of come to a conclusion based on the interval that we get. Is there convincing evidence that the opinions have changed? Now, for part A, where did they get that 13%? Well, in the poll they did in 2013, 38% were dissatisfied. In the poll they did in 2012, 25%. So that is an increase of 13, but why should we use the confidence interval to estimate? Because of the idea of sampling variability, right? Sampling variability says that when you take samples, there's going to be some variability, right? It's not going to be the exact same every single time. So because of this idea of sampling variability, the difference of 0.13 is unlikely exactly correct between the 2 populations. That's why we're going to use an interval to estimate the true difference in the proportions. So Now we want to go ahead and construct and interpret our confidence interval. What are we doing? A 90%? So, scroll this down. Use the results of these polls to construct and interpret a 90% confidence interval for the change in the proportion of U.S. adults who would agree with the statement about gun laws. So, first step is to state, right? In our state, we're going to define our parameters, say which confidence level we want to do. So, for this, let's go here. What do we want to do? We want to estimate, and this is where I was using the different subscripts, right? P sub 2013 minus P sub 2012, right? The difference of the 2 years, proportions, at a 90% confidence interval where, and then I have to define each parameter, okay? So P sub 2013 is going to be the true proportion of U.S. adults that were dissatisfied with gun laws in 2013, and then on the same vein, P sub 2012 is going to be the true proportion of adults that were dissatisfied in 2012. So we need to make sure we define each parameter as well as state the level of confidence that we are doing for our confidence interval. So you may be wondering which proportion should go first, right, when you're subtracting. It really isn't super important which one you do first. It just matters then how you would interpret your results, right? So since in part A it did say we're increasing by 13 percentage points over time, that's why I'm using the most recent minus the previous one to do that. All right, after state comes plan. In our plan, we have to say what we're going to use. We're going to construct, I should say, a 2-sample Z interval for a difference between 2 proportions. You have to have each of those parts. So before we did 1 sample, now it's 2 sample. Z interval is important, and then so is the difference between 2 proportions. Now we're going to check our conditions. So we have random, we have normal, and we have independent. So let's see what conditions we're going to do here. Random, both samples were randomly taken. It says that in the problem, so that is important. Okay. When it comes to normal, we have a couple things to calculate. So up here, I just wrote down what my p-hats were, right? The sample statistics that I got from each set of data. So the proportion from 2013 was 0.38, proportion from 2012 was 0.25. They did happen to both take samples of the same size. You don't have to though, right? They happen to in this instance, but you don't have to have sample sizes that are the same. You do, however, have to show that all of them are at least 10. Okay, so showing our calculations, they're at least 10. They didn't come out exactly, so I kind of just rounded appropriately so we could see what they worked out to. So we've done random, we've done normal. Our last one is independent. So samples are independent of each other, right? And we have to say about the 10% condition for each population. So 1,011 is less than 10% of the population of U.S. adults, in both 2013 and in 2012. We have to mention both populations. So even though it's the same U.S. population, it's different years, so the population has changed. And it's definitely safe to say that 1,011 is less than 10% of the population in both of those years. So now that we've verified our conditions, let's go ahead and construct our interval. So, can we see this? Yes. So it's the difference of our proportions. So if I'm doing 2013 minus 2012, make sure you put it in the proper order. That is important. Whatever order you chose, just stick with that order. So 0.38 minus 0.25 plus or minus 1.645 is the critical value, right, my Z star, for a 90% confidence interval, right? Remember, that's when we would do the inverse norm for, what, if it's 90, 100 minus 90 is 10, so we'd look up 0.05 for the inverse norm. It's also on the bottom of that T table if you ever don't like using your calculator. And then we multiply that, so this is times, by this big old thing right here. That is our standard deviation of our sampling distribution. Sometimes we call that the standard error, right? And we're using p-hat for each of these. So subtract it, you get one value. Add it, you get another value. I will show you how to do this in your calculator so you don't have to actually compute that. I would make sure you know how to compute it, right? It's important to know how to plug it into your calculator and actually get the value. Yeah. So we get an interval of 0.096 to 0.163. Now all that's left is to conclude. So we are 90% confident that the true proportion change, or you could say that the true difference in proportions in adult opinions of gun control from 2012 to 2013 is between 0.096 and 0.163. So you do have to say something about either the difference of proportions or the change in proportions, because that's what we were estimating here, right? The difference in those proportions. All right, so the last question. Based on the interval, is there convincing evidence that opinions have changed? Now, if they haven't changed, what would that interval look like, right? 0 is not in our interval, okay? If the difference between the proportions was 0, that means that there wouldn't be a difference, right? It would be 0. There wouldn't be a change. So because 0 is not in the interval, we do have evidence that it has changed. So because 0 is not in our interval, we do have evidence of change. If 0 was in the interval, we would think that the two proportions were the same, therefore no change. Now, there is a way, like I said, to do this in your calculator. So let's fill in the calculator steps so you can try that out, see if it worked for this example, and then for the next example that you're going to do on your own. So if you're doing this in your calculator, you're going to go to Stat, and you're going to go to Tests. And in most calculators, it's option B, and it's called 2 proportion Z int for interval. Okay. You're going to enter in the information. Instead of using p-hats, though, you have to enter in the x's, right? x1 and x2. You have to make sure they are whole numbers, so that's important. That's one of the reasons why up here in the normal step, I rounded these to whole numbers, because if I were to do this in my calculator, those are the values I would have to plug in. Okay. Use the calculator for the do part, but you still want to write out the formula, and then you can go back and double check it the long way, but I would recommend using the calculator for doing the calculations. Okay. All right, there's another example like this on the next page. You're going to do that on your own. There will be a video that walks you through that solution, so you can check it after you've tried it on your own. So stay tuned for the next video.